Okay, I am live. Okay, see you there. Okay. Okay. Alrighty. Good morning. Good morning. Good morning. All right, we have that. We have that. We have two people here. Great. 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 Welcome. Good morning. Good morning. I see Liana chiming in on the actual classroom, which is nice. Okay. All right. We'll just wait for a few more of you to show up. Okay. Wow, a lot of you are chiming in. I like it. Okay, welcome, welcome, welcome. We'll wait for a few more of you to show up. Let's see. The graphing part's going to be tough. All right. All right. Let's see who's here. Let's see who's showing up. Hi, good morning, Liana. Good morning, Sarah. Your classmates are coming. I need another cup of coffee, so I'm going to give you about 10 seconds. Oh, I'll give you more time. Now my voice sounds like it's far away. I'm still with you guys. Just wait for the class to fill up. It's almost like I'm at the door of room 408, waiting for everyone to walk in. And you don't have to have the bad school breakfast. You can have your own breakfast. You don't have to have fake cereal. You can have real cereal, real milk. Wow, you guys have it good. So we'll wait another, like, 30 seconds. How many of you? Only 5 of you. Good morning, Gianni. I have only 5 of you here in the stream. I can't believe it. But then again, this might be off because, again, the stream is just so terrible. So concurrent viewers. So I'm being told now, because I'm using this YouTube platform, that there are only 5 of you. Good morning, Jocelyn. All right, I got my coffee. Nice. There's more of you here. Also, please don't hesitate to chime in the chat, in the live chat in YouTube. All right. So I'm going to skip a section here only because to show the graphing or to do the graphing is going to be really, really tough. The tools that I have are limited as it is, number one. Number two, it's just the delay, the lag is pretty bad. It's pretty bad. But with regards to the graphing, it's not going to be, too intense. I'm going to, share everything with you. You'll have the solutions and you'll have access to a graphing calculator. So I wouldn't worry too much about the graphing section that we're going to have to cover. But we can definitely proceed with the next section. So this should be in your class notes. I'm just trying to think which one. I have to go into your class also. So we're looking in the learning materials for chapter 4. Let's see. Not one-to-one, not logarithm. I think we are in, let's see. Right, so we're still in this exponential functions handout. We are in the guided practice. We are in question 1. Somewhere in the middle of the page where it says solve for all values of x, and we're looking at 1/3. That entire fractional base raised to the power of x. So it's still the same handout. It's just somewhere in the middle. Good morning, Cindy. There's only 9 of you. Where's everyone? Is 9 a.m. too early still? So 7 a.m. was bad, right? I guess, or I don't know. But I'm glad that you're here. Good morning, Melissa. I'm enjoying my coffee. I had to resort to Keurig K-Cup Dunkin'. I went to Astoria yesterday, but I was too lazy to go into the supermarket. Good morning, Valentina. All right, so let's see if the whiteboard is working. Let's see. What should I write? This is what I have to buy later. Very exciting. So if you see if the whiteboard is functioning, please write today's word. Good morning, Josh. So if the whiteboard is functioning, please write today's word of the word of the day, I guess. Anyone? So again, I provided the links to the whiteboard, or the link to the whiteboard. I wrote a word on the whiteboard. Yes, yes, it's so exciting, this word, gravel. So because I'm sitting here in my dining room table, I've taken pictures from, or looking into the backyard. I hope you saw the cardinal, and I think maybe I attached a squirrel drinking out of water. I've aged, and I bought a bird bath. So don't tell anyone, this is really sad. So I bought a bird bath, and the reason being is that I enjoyed seeing the birds on my deck. I would never have thought that I would enjoy something like that in a million years. It may happen to you guys. It may happen. You'll see. You may enjoy that at some point. It's all right if you don't enjoy it today. It's all right if you think that I'm old, I guess. But I need gravel to support the bird bath. Gravel is just a bunch of little rocks that serve as weight. That's all it is. Very exciting. I know. That's it. Enough of old man talk. I'm getting rid of the gravel, and we're focusing on what we need to do today. But thank you again for checking that out. So we have to solve now for this exponent. And we have a base of 1/3. So I'm going to write it here. So we got rid of the gravel. That's my job for today. I have to go to Home Depot and buy gravel. Very exciting. So we have 1/3 as a base. And we're going to raise that to the power of x. And then we have here 81. So it's going to be a little tough to solve for it in its current state. But I want to say that we touched upon this when we were still in a brick and mortar environment. So in other words, what we need to do is we have to figure out a way to make the bases the same, right? So if we have something like this as an example, I'm pretty sure we did this. Like I said something like this: 5 raised to the power of 1, right? Or 2. Excuse me. We'll go a little more complicated. 5 raised to the power of 2. We know that's 25. Right? I hope so. So I'm scrolling down. So I could also rewrite 25 here as 5 raised to some power. I could. I'm just, basically taking 25 and rewriting it as a base raised to some power. But we know that 5 squared is equal to 25. But apparently now it's equal to some power, or equal to some value that's 5 raised to the x power. So it's almost irrelevant, not irrelevant, but I don't really need to now focus on this base of 5. So yes, these bases are the same, but what I really care about is this, what I'm going to highlight. So I'm going to highlight 2 and x. And really, if we have the same base, then the exponents are going to be equal. So that's going to be the key to solving these exponential equations. So same base, we're able to set the exponents equal to one another. So in other words, if I scroll down, again, we're scrolling down. All right, so let me go back up a little. So in other words, in this case, when you have 5 raised to the power of 2, and it's equal to 5 raised to the power of x, to solve for x, we in this case set x equal to 2, and that will satisfy the equation. Here it's a little bit different, because now you have 1/3 raised to the power of x. But in our discussion from yesterday, so again, we're still in this digital whiteboard, scrolling down. So here I have 1/3 raised to the power of x, and that equals to 81. But we can rewrite 1/3, and watch what I rewrite it as. 3 raised to the -1 power, and that's still all equal to 81. So hopefully, is the whiteboard working? Are you able to see it? Is it functioning? Am I moving too fast? I just need to make sure that you're still with me, that you can still see what I'm writing. Are we good out there? You're still able to keep up with the whiteboard? I just need to make sure that you're alive out there. Any feedback? It's working. Thank you, Brittany. Thank you, Irene. Thank you, Leanna. Thank you. All right. So I'm going to rewrite 81. So it needs to match with the power of 3. So now I'm focused here, and I have to figure out now, how do I rewrite 81 with a power of 3? That's number 1. And then I have to figure out what my exponent will be. So right now I have 3 to the -1 power, and all that raised to the power of x, excuse me, and that should equal to 3 raised to a power. But what is that power? So we could do the following. We know that 9 times 9 is 81, but 9 can be expressed as 3 times 3. So in other words, we have 3 being multiplied 4 times. So 3 times 3 times 3 times 3, or this thing is raised to the power of 4. So now, with our powers rule, power of a power, I'm able to multiply -1 and x. So we have the following. We have then 3 raised to the power of -x. That should equal to 3 raised to the power of 4. So I've achieved the goal of having the same base, and now all I care about is taking this exponent and setting it equal to the other exponent. So in other words, now this becomes negative x equals to 4, or x equals to -4. So that should be the final answer. So let me project that in our PowerPoint. So this is all in the PowerPoint now. It should come to life any second. So again, if my chicken scratch was, really bad, you'll see it in front of you hopefully any second now. There we go. So this is going to change quickly now, this screen, and we'll have the step-by-step process. So basically, in order to solve exponential equations, we need to make sure that the base is the same, and once we've done that, then we can solve for the exponent, which in this case is the one, or what has the variable that we need to solve for. So basically everything that we just went over on the whiteboard is displayed here. So, next question is slightly more difficult, slightly, not so much. And I'm going to write this on the whiteboard. So we're scrolling down. And if at any moment you have a question, just please hold on. Thank you. Eleni, can we just use log or do we have to do these steps? We're getting to log. We're getting to log. If you remember log, then that works too. But I'm not going to touch upon log until we have no choice. And in a future exam, when that does happen, I still have to think about that. Future exam to be determined. So when we do look at certain topics within this chapter, you're going to have to solve it using these rules of exponents, creating the same base. So I'll say something like, please use the powers or the rules of exponents to solve this equation. And then another set of instructions can be, please use the rules of logarithms to solve this equation. But if you feel comfortable using logs now, go right ahead. I'm not going to focus on that just yet. It's coming, and I'm going to use it when we have no choice. All right, so this next example, what is it, 2? So we're looking now here, and again, thank you. Eleni actually beat me to it. What I was going to say is, if you have any question at any moment, just write it in, and when I go back to looking at the question or this chat section, I will address your question. So thank you for that, Eleni. All right, so we're looking at this next example. This should be 2 raised to the power of x plus 4, and we're going to set that equal to 8 raised to the power of x minus 6. Remember the goal. The goal is this, to get these values to be the same. 2 is already in a simplified form, or it's already prime. So that's what we essentially want. We want a base that's prime, more often than not. I mean, if they're not prime, but they're the same, that will work. But that's the goal. So we're forced to work with 8, and we have to figure out a base that will work with 2. Luckily, we can rewrite 8 as 2, but we have to raise it to a power. And just because we are in this environment and because of the delay, I hate doing it. I'm just going to give you the solution here. And if we raise 2 to the power of 3, now we're in business. So we have the same base. And don't forget, when we're raising a power to a power, I have to multiply. So I'm going to multiply 3 into x minus 6. So I'm going to put x minus 6 in parentheses so that this way you know that you're going to have to distribute. So I have the same base. So I'm going to rewrite it this way just to stay consistent. So again, I'm moving down. I hope you're following along. I'm really curious as to what method you're using to follow me on the whiteboard. I wonder if some of you like zoom out, zoom in, or whatever. Just curious, a thought, if you will. All right, so I'm going to rewrite this as 2 raised to the power of x plus 4. This will equal to 2 raised to the power of 3 times x minus 6. So that's really what we're looking at. So what we care about is not so much the base. What we really care about is this now. Since the base is the same, I just care for our exponents. And we're going to set this equal. So it becomes x plus 4 equals to 3 times x minus 6. Now this becomes middle school, 6th grade math. So if we can get it back to being, simple as possible, then this part of the chapter is not going to be too difficult. I hope you didn't hear me slurp my coffee. And if you did, I apologize. Or actually, no, sorry, not sorry. I hope you're laughing with me and not at me. So in solving this, I'll give you a second to solve. I mean, you may have already done this just because it's pretty simple once you get the hang of it. And if you did, you'll notice the following. So if we did this correctly and solving for x, you should have x equals to 11. Did that show up on your end? It's coming. It's coming. There it is. All right. So again, this screen is not going to stay up there for that long. So if you want, you can take a picture. You can do whatever screenshot. I don't care. You can even take notes quickly if you'd like. But this will be the solution. And you can check just to verify that it is in fact correct. And in this case, it will be. All right, so now slightly more complicated example. What happened here? It's okay. Thank you, Mamadou. I don't know what it's okay. Maybe me drinking my coffee? I hope so. Alrighty, so let's look at this next example. So scrolling down on the whiteboard, we're looking at, and just so you know, this whiteboard isn't free. I thought it was free, so I was really excited. I'm like, yeah, this is awesome. And yesterday, they pulled the rug. They're like, oh, your premium trial membership has expired. We're now going to give you the cheap version with ads and limited functions, and I was not going to have that. So now I'm paying for this whiteboard. You guys have it good, just so you know. I'm giving you the best that I can because you guys deserve it. I'm being serious about that one. Before I was, half sarcastic about the board and stuff, but you definitely deserve to learn in the best way possible. That's why it doesn't bother me in the least. All right, so let's look here. So x raised to the power of 4/3. And this will equal to 81. So what we need to do, so now here it's a little bit different, right? So here, in this case, the exponent is not what we have to solve for. We have to solve for the base. So what we need to do is the following. I mean, it's not going to make any sense here to rewrite 81. We don't really need to, but what we need to do is interpret this. We need to interpret that exponent, 4 divided by 3. But if you remember from our discussion yesterday, remember that denominator. The denominator is everything. That's going to tell us how to write this as a root. So remember, so this becomes some root of x, but not just any root. It will be a cubic root. And then this whole thing is going to get raised to the power of 4. So this will be the cubic root of x, all of that raised to the power 4. That will equal to 81. But then the question is this: how do I get rid of that 4th power? So that's where it becomes a little bit tricky. So there's a couple of ways that we can do this actually. So we can do it this way. Right, so here, I'm going to do it this way. So I'm going to get rid of a power of 4 by multiplying each side by a fraction, the exponent. So I want to get rid of this exponent here. All right, so to do that, I'm just trying to find the room here, so just give me 1 second. So this whole thing, I'm going to raise to the power of 1/4. And then that means I have to raise this whole thing to the power of 1/4. Because what ends up happening is this. And I hope some of you are saying in your mind, why aren't we doing this a slightly easier way? And we are. I'm going to go to that way in 1 second. But if for whatever reason your mind has gone here, this is what ends up happening. So the 4 and the 1/4 disappear. What I just circled. So scrolling down, we have radical, or the cubic root of x, it's going to equal to 81 raised to the power of 1/4. Or in other words, what we need is the cubic, or the quartic root of 81. So don't forget, when you're in the denominator, you have a fractional exponent. You can take that denominator and create a root out of it. Here it's the fourth root, if you will, of 81. But what value, when you raise it to the fourth power, will give you 81? And we looked at that already. So again, hopefully you scroll down. That will be 3. And now you have the cubic root of x equals to 3. But here's the only thing. When we have, so just something to note. So when we have the following, when we have any type of even numbered, whether it's a root, right, and especially as a root, excuse me. So we're looking at even numbered roots. We have a square root, a fourth root, a sixth root, eighth root, etc. We have to write it as plus or minus. So we can't forget to do that. So in order to solve this, now to get rid of the cubic root, we would take this to the power of 3. And then we're left with this. That x will equal to plus or minus 27. So I'm going to show you how we can do this basically like in one shot. So we have x equals plus or minus 27, but if we did this from the get-go, here we have 4/3, x raised to the power 4/3, that equals to 81. I'm just showing you the quick alternative. You can raise this to the power of 3/4, raise this to the power of 3/4. That gets rid of this fraction here, gone, gone, and then you're left with this. So again, you have alternatives. So you have x is equal to 81 raised to the power of 3/4, but you already know what happens in that case. So again, we're just scrolling down. That x will equal to the quartic root of 81, but all of that gets raised to the power of 3. And we already know what that is, plus or minus 3 raised to the power of 3, or just plus or minus 27. So it's the same difference. So that's how this one example goes over it. So this was our original approach. And the approach that I'm going through now, I think is here. Right, let me see what happens here. Yeah, this next one, I don't even want to confuse you, or I don't want to, spend too much time going over it. It's basically what we just did, but they're taking it a little bit deeper. So I wouldn't really be too concerned with this approach, but just look that in each case that x is going to equal to plus or minus 27. So normally I would give you time to try these on your own, but I want to maximize the time that we have because again, 40 something minutes. I don't know. You guys like 42 or 43 minutes? I'm curious because remember, oh, hold on. I have a question here. I mean, you didn't need to apologize. I didn't mean any disrespect. No, Mama Dul. Oh, it's okay. Good morning. Are we going over the homework? I had a few questions on the second page. Time permitting, Kyle. I'm deep into going through this exponent stuff right now, and I'm trying to maximize time. So hopefully I have some time after to go over it. But as I was saying, normally I would give you time to work, but just because of the reduced class time, I'm just going to give you the solutions here. So here you have try on your own, and these would be the solutions to that. So when you do, in fact, want to attempt this on your own, now you have a key, and it just will reinforce what we went over. So as you copy this down, take a screenshot, picture, whatever it is that you're doing, my question to the class now, do you like the 42-minute format of a class, or do you prefer the 80-minute format? I'm curious. So again, I'm giving everyone just an opportunity to copy these questions, or the solutions, excuse me. But my question to the class, because I am genuinely curious, do you like the 42-minute format or our old 80-minute format? 42, all right. Honest, I like it. Anyone else? All right, all right. I respect that. There's definitely pros and cons. Thank you for your honesty, ladies. Brittany and Cindy. Okay. All right, so, Leah likes 80. I kind of want to side with Leah because this way I don't have to rush as much and you do get time to practice. And, I need 80 minutes to talk about my bird bath. Sorry. So, moving along. So, we're going to, related, we're still continuing with exponents. I believe this will be the second half of the handout. Yes. All right. So, this is the back of that handout, but normally I would have given you some time to think about this picture, this painting, the deal of a lifetime. Deal of a lifetime. What is this? The cost of Manhattan Island. This is in 1620, a long time ago. Long time ago. For $24. Oh my God. 24 bucks. You're lucky if you get a quality lunch for $24. Right? Think about it. And in 1620, you could buy Manhattan. Anyway, but the idea that, or why this is brought up, is because we have to think about interest. So, placing $24 into a bank account that collects interest at 5% would amass $5.1 billion after 393 years. We could have looked at it in 400 years. That might have been more appropriate, but I will say that it's pretty close to that value. So look at that. So $24 over time with interest, but not just simple interest. Simple interest, I think we'd have a different value. But I think what we're looking at here is a compounded interest. Okay, so simple interest. It's pretty simple. So interest is the dollar amount that we get paid for lending money or pay for borrowing money. I wonder how many of you lend money to your friends and then demand interest if they take a long time to pay you back. I wonder if there's some of you out there that have lent money and never got any back. I hope that's never happened to you guys. True story, went away many years ago. I lent a friend 50 bucks. This is like back in 2004. I see this person every now and then, and I bring it up to them like, yo, I need my 50 bucks. Now it's worth it that he never paid me back because I could bother him from now until the end of time. And then I'll talk about interest, be like, hey, that 50 bucks is now like, I don't know, that it's worth like $2,000 to me. It's, not doing real calculation just to, to bust his chops. Anyway, so the amount of money that we deposit or borrow is called the principal. So principal, again, this is the concept that you'll deal with more so later on in life. Oh, well, not really later on. If you're going to take out a loan, period, you have principal that you need to pay off, and then you're going to pay off interest. So something to think about when we go to college. Hopefully you can enter a brick and mortar environment come the fall. We'll see. Hopefully you do. But anyway, college is expensive. You have to pay the actual cost of attending college. But if you borrow, you're going to have to pay interest. So the principal is the amount of money that we deposit or borrow. And interest is going to depend on a few things. The amount that you borrow or the principal, or the amount that you lend, interest rate, and time. So simple interest is just going to be simply principal times rate times time. So if we look at this first example, so it deals with Irene depositing $2,000 into a savings account at Solorzano Bank. Wow, which has a rate of 6%. So just to let you know, I'm going to crush you now. Typically, banks will not give you that much interest. If banks were giving this much interest, everyone would flood or place their money into a bank. Typically, a bank will give you less than 1% if you deposit your savings into the bank. You're basically giving the bank free money because the bank is not just going to sit on that money. They'll use that money and then they'll redirect it or invest it elsewhere. Typically, they'll give it out in the form of loans, where then they can charge a pretty high amount of interest. Not so high, not an illegal amount, but enough where it's legally within limits and for them to make money. Okay, so where were we? So if we look at this next example, so $2,000 into Solorzano Bank at a rate of 6%. So at the end of the first year, not doing anything other than physically walking to the bank. So imagine Irene walks to Solorzano Bank, she puts in 2 G's, comes back 1 year later, those 2 G's now have accrued or earned 120 bucks. Not bad. No risk. Maybe just risking crossing the street. I don't know, but in theory, no risk. Just walking to the bank, depositing that money, $120. This is just simple interest. So if we look at the next example, so again, we're moving along. This is in the back of the handout. All right. And if we look at the second example deals with a student took out a simple interest loan for $1,800 for 2 years at a rate of 8% to purchase a used car. Wow. All right. So if we look at our simple interest formula, so I'm going to use the board now. So going back to the board, oops. So our interest rate here, so we said interest is equal to principal times the rate times the time. So here our principal, what we're borrowing is $1,800. The rate in this example is 8%, and the time is 2 years. So basically when we calculate this, the question is asking, find the interest, so only the interest. So if we multiply all of this out, we should have about $288. So at the end, it shouldn't be at the end of the first year, it should just be at the end of this loan. So that I have to correct on my end. At the end of the loan, right? Because student took out a simple interest loan for 2 years. So essentially borrowing $1,800 will cost you $288 on top of that when you pay back. But this is really the more realistic example of interest, and that's compounded interest. And this is where if you're going to invest your dollars, you're going to want to invest into a type of an account, that will earn compounded interest. So interest that just grows on top of interest. So there's a formula, there's a derivation or a way to derive the formula that you see in front of your screen right now. And that formula is A is equal to P times 1 plus R, that entire sum, raised to the power of T. It sounds kind of, or looks intimidating, but the reality it's this. You're going to deposit something year one. Year one, that money will grow. It'll grow by a certain amount. And then in year two, your money will grow not by the original amount that you put in, but by all the money that is now in that account, including the interest. So something like this, if you look at the board, so let's say here, you have $1,000, this is year one. At the end of year two, right, year one, actually no, year zero. Let's do this. So year zero, or day one, you throw in $1,000. At the end of the year, let's say you get 1,100. as an example. So then that's sitting in your account. Then year 2, this amount is going to grow. And it could grow to, I don't know, I'm just making this up. I'm exaggerating this. Exaggerate, complete exaggeration. But just to show you that it's building not on the original 1,000, but it's going to be building over this $1,100 value. And then in year 3, it'll be building off of the 1,250 value. I'm just making these numbers up just to show you that it's not going to be building off of your original amount, but what you have in the account over time. So this is kind of a sneak peek as to where we're going, because it is 9:41. So let's see, just some final thoughts for today. So we went over exponential functions. You have homework that's attached to that in the classwork. I'll go in and I'll just try to simplify what you have to complete, because I think whatever I included, it includes also stuff on interest, so I'll just adjust that so that you have less to do. And Friday we have class to normal class. And I think next week is going to be a little bit different. I'm not too sure. I have to talk to Mr. Randall because I think each day is going to be a different theme. So in lieu of our spring break, they're going to do something different for students and families. So I'll have more updates by the end of the week. But the homework I'll adjust. You'll definitely have homework due Friday. And we're going to continue this discussion on that day. If you have any questions, again, feel free to send me a message. You can chat in the classroom or just send me an email, whatever it is. I'll be here for you. And that's it for today. And hopefully the next time that we meet, I'll have a bird bath and I can take a picture of some birds. That's it. Very exciting times at Casa Alarcon. And I hope everyone is doing well at home. Again, have a great next 3 days, or however many days leading up to Friday. Losing track of days and counting, being confined in this space. But I just wish you guys, stay well, stay healthy, and I'll see you soon. Oh, Leah's saying we have class on Friday. I thought we have Thursday and Friday off. No, so the Department of Education has put a stop to any time off because of what's happening. You're welcome, Sarah. Thank you. So yeah, so again, we have class Thursday and Friday, and we have some type of schedule for next week. And more will be shared with your teachers and with Academy. I'm sure you'll have something that's going to come through Scheduler, so just stay tuned for that. But that's it for me for today. Have a great day, and I'll see you soon.